Hi everybody. I've been making a bunch of these videos for the algebra class, but I don't think I've made many for you, if any. So this is basically a way I can explain to you guys the content of what we're doing in a way that I know you're getting the information you need. So when we talk about surface area of anything, we're basically talking about if you think about like painting, right? When you paint a room, you think about how much paint do you need to cover the walls in the room. Well, when you talk about a solid object, it's the same thing. If you talk about the surface area of a cylinder, a good thing, a good visual is think of a soup can. Think of any kind of canned good. That's usually a cylinder, right? So think about how much paint would you need to cover that? Like how many square inches or square centimeters, square feet, whatever of paint would you need to cover that? Another way to think about it is if you had to wrap an object that was a cylinder, how much wrapping paper would you need? So that's the surface area. It's all the outside face of that solid. Okay, so what we need to talk about before we can come up with a formula for surface area is how do we make sense of what it is. So I don't know if you guys remember this, but I know a lot of you in 7th grade talked about nets of solids, and a lot of you who were in Hibberd did like activities where you actually built nets of things. So when you're talking about the net of a solid, it's basically what would happen if you cut something open. So if I take this Campbell soup can that we're looking at here, basically I've got two circles, right? We've got the top circle and I've got the bottom circle. And then if you imagine, like if any of you have ever done this, where you've done a Campbell soup label drive where you cut it, right? Cut the label. And then when you peel it off, basically what you get is you get a rectangle, right? You get a rectangle. That's what it looks like. It's just, it's a piece of paper that when you take it and then when you curl it around, right? Then it looks like a cylinder, but it starts out just as a rectangle. And I've seen a lot of you take pieces of paper and roll them into a tube. Well, it starts as a rectangle. So if you can go backwards and think of a cylinder and cutting it open, it opens up into the form of a rectangle. So if we understand that, then we can come up with a formula because we're talking about area. So let's start with our bases, which are actually the easiest part of this. So we've got two of them, right? You've got two bases, and I know that one base, the area of it, of a circle, is pi r squared. So that's pi r squared, and this is pi r squared. So we've got this and this for these guys. So now let's talk about this. Well, if you're finding the area of a rectangle, it's just length times width. Pretty easy, right? So think about this in terms of the cylinder. Well, your width would be here, your length would be here. Your width is equal to the height of your cylinder. So that's easy. The hard part with these is figuring out what your length is. Well, because they don't give you the length of that when you do it. But what you do know is that this basically folds around this circle when it's curled up and molded into the cylinder shape, right? Well, if that curls all the way around the circle and then stops when it gets there, think about what is the perimeter of a circle. Well, the perimeter of a circle is its circumference. So the length of this rectangle in the net is equal to the circumference of the base. So it's 2 times pi times r. So when you come up with what your length times width is, your length is 2 times pi times r times your height. So now we've got somewhere to go with this, right? So let's take this, come here. Your surface area of your cylinder is equal to 2 pi r squared. That's our two bases, right? And then your 2 pi r h, which is your lateral side, right? So there you go. That's how you come up with the formula for a cylinder. So I'm going to stop the video here, and then on the second video you will have 2 examples of problems using this formula. So that's how you come up with the formula.